Good morning, ladies and gentlemen. What we're looking at now is how to calculate the distance between 2 points that are on the same latitude. What that means is that if you have a point here, and another point on the same latitude around the world, how to calculate that distance. Alright, first what you need to do is calculate the radius of that small circle they're on. You see how this here is a small circle? And you can calculate that radius using SOHCAHTOA. Turns out you can throw out a little right angle here. You know the radius, and you know that this radius here, this radius line, is parallel to the radius of the great circle. Because it's parallel to the radius of the great circle, it means that the angle north up to that latitude will be the same as this angle here, and therefore you can use adjacent and hypotenuse to determine the radius of the small circle. Now the radius of the small circle can be given by r is equal to 6,400 times cos theta, where theta is the angle north. Alright? Then, these two are separated along this small circle here by another angle. That angle, that gap there, we'll call alpha. So therefore the distance along that small circle, that red line there with the alpha here, will be found by doing this equation here. The length of that arc, we call it L or S or C for part circumference, equals alpha, which is the distance around, over 360, times 2 times pi times r. We've calculated r previously to be this. Therefore, the formula you really need to know and be familiar with is that the distance between two places on the same latitude is alpha, the angle between them on that latitude, over 360 times 2 pi, times 6,400 cos theta. Theta is how far north or south they are. Alright, let's put that into application. Find the radius of the small circle which has a parallel latitude of 15 degrees south. Alright, 15 degrees south we can see is here. So what we're looking for is the radius of this circle cutting around the world at that southing. Now, from side on, what this looks like is we're at the equator. That's the equator. We've gone 15 degrees south. And we now want to know what this is here. So, right angle, we know that we've got an angle here of 15. We can take out that triangle, 15. We'd like to find this. We know this is 6,400, and we know this is a right angle. We can say that the radius of this line, or here, you'll have cos theta equals adjacent over hypotenuse. Cos 15 equals x over 6,400. X is equal to 6,400 multiplied by cos 15. Excuse me 1 second. 6,400 times cos 15. The radius of that circle is 5892.15 kilometers. Right? And as you'd expect, it is less than the radius of the great circle, less than the 6,400. Alright. A plane flies along a path. A plane flies on a path along a parallel latitude between A, with coordinates this, and B. Find the radius of the parallel latitude to the nearest meter, and the distance travelled by plane to the nearest kilometre. So now, they wouldn't give you a sketch like this, but I think it's worth drawing out approximately where these places are. 64 south, it's quite a long way south. 64 south, 31 east would be here-ish. Then we want 64 south, 150 east is round there. Now note, it's on this same small circle. And we're eventually asked in part B to find the distance around the circle between those 2 points. Alright, so in A, we want to find the radius. The radius is 6,400 cos of the angle between them. Now, for us, the angle between them, it's best to take a cut of that small circle And let's see if we can work out the angle between them. So a cut on that small circle there. Here is the 0 line. 0. 1 is 31 degrees. Yuck. Ignore me. This explanation is for part B. Sorry if I confused you. If you look at the definition above, the theta in the cos bit here is how far north or south they are. Here, they're 64 degrees south. 64 goes there. Easy mistake to make. Apologies, I shouldn't be making a video. Times cosine 64. Please double check when you're using the two angles which one you're meant to be using. And the result is the radius of that sphere is this. That sphere, that circle. Now note, it says to the nearest meter. So be careful here. You would like to multiply this by 1,000 and keep the decimals going. So you want to go 2805,575 meters. Couple of traps there. Alright, now part B, we are going to use the formula we wrote above. We've already calculated that bit as the radius of the small circle. We just need to find this A here. Now, this is where we look on that small circle from above and note that one is 31 degrees east and the other is 150 degrees east. So one is 31 degrees east and the other is 150. Meaning that the angle between them, the angle that subtends this arc, so that angle there, will be 150 take 31, which equals 119. Alright, so then the distance travelled by the plane is given by 119 over 360 times 2 times pi times the radius which we found above, which can be written as 6,400 cos 64, which gives us an answer of kilometre to the nearest kilometre, so we don't need those. Alright, that is the last question. Alright, sorry about the mess up in the end answer, but good to watch me make mistakes so you don't make them. This angle has to be the north-south one. This angle is the number of degrees they're separated east and west. Alright, thank you very much. Please make sure you take nice, neat notes. Do try and draw some sort of diagram like that to illustrate to yourself where these places are on the world. Alright, thank you very much. Bye.